everyone, here's a video on the transformations of exponential functions. Okay, so to get started with exponential functions, some of you are probably sitting there thinking like, how do I know what's an exponential function? So here is a real world example. So there's been a measles outbreak at Disneyland. About 70 people have been infected. Each of them can infect up to 13 other people during a 2-week incubation period. So what that's saying is for every single person, say I'm infected with measles, that I come in contact with in the next 2 weeks, and typically I come in contact with about 13 people, those 13 people will be infected by measles. So now this is asking after 8 weeks, how many people will be infected? So now we're going to take a look at it. So the first thing I have, so the first time, so 13 to the 0 power, I'm at 70. So those 70 people, each one of them can come in contact with 13 people. So we got to do 70 times 13. When we do that, we get 910. So after the first 2 weeks, 910 people have been infected. But we got to keep going, so we got to get to 8 weeks. So next thing we're going to do is 910 times 13. Now we are at 11,830. So a month in, 11,830 people are infected with the measles. Now those 11,830 people are going to each come in contact with 13 more people. So now we are at 153,709 people are infected with measles. And this is only after 6 weeks. So we're not even done yet. So we got to keep going. So these 153,790 people are each going to come in contact with 13 people each. So we're going to have a total of 1,999,270 people infected with the measles. Now, that escalated super quick because we started out with only 70 people being infected with the measles, and then we landed at being about 2 million people being infected with the measles in just 8 weeks. So this is where we have our exponents at work. So in other words, what this is saying is that the infected people is equal to 70 times 13 to the x. Now this is the type of equation that we haven't ever seen before. So we're going to take it all step by step and break down what the equation actually is meaning. So the general or the standard form of an exponential function, you have y equals plus or minus a times b raised to the plus or minus x minus h power plus k on the outside. So first off, the plus or minus is right under a. It's just like every other function is a reflection of the x-axis. In your a is a stretch or compression. Now this part right here with the b, this is what's new. This is the main part. So b is your parent or your base. So every single exponential function has its own parent. So the parent for every single exponential function is going to be y equals b to the x. Okay, so every single function has its own parent, and I'll show you that in a little bit. Alright, the plus or minus in the exponent. That's going to tell you it's a reflection of the y-axis. Then your x minus h, your h is still your horizontal movement, so it's going to go left or right. Then you have your plus k. Your k is still a translation of up or down. But now what's different is your k is an asymptote. And I know you don't know what that means yet, which is totally okay, because I'm going to go over the definition in about 1 minute. Okay, the characteristics of the exponential functions. So the first is the variables of the exponent. So some of you are thinking like, oh, that's super hard, but it really is not that difficult. The next thing, the y-intercept is produced when the exponent equals 0. And then as we know, anything to the 0 power is equal to 1. So that means for the parent function, which really step number 5, the parent parent function, the y-intercept, or it always crosses through the point 0, 1, because your y-intercept is going to be equal to 1. Next thing, our domain is always negative infinity to positive infinity, and then the boundary of our range is identified by the value of k in the equation, which is also the asymptote. Okay, now what is an asymptote? So by definition, an asymptote is a straight line approached by a given curve as one of the variables in the equation of the curve approaches infinity. So this line can be a vertical line, so it can be y equals a number, or a horizontal line, x equals a number. But for our purposes right now, with learning exponential functions, it's going to be a vertical, or it's going to be a horizontal, it's going to be, I have vertical and horizontal mixed up. I'm so sorry about that. If it's a vertical line, that means it's straight up or down. It's x equals a number. And if it's horizontal, it's y equals a number. Okay? And then for us, all of our asymptotes right now are going to be the horizontal. Okay, we're going to have horizontal asymptotes. So that's, whenever I was explaining it to my kids today, we discussed, or I asked if y'all have seen this little joke down here, but the asymptotic high five, it's the fun never ends because their hands keep approaching each other. And since you have an asymptote at x equals 0, their hands never touch, so that's why the fun never ends, but y'all probably don't get that math joke, but it's okay. Alright, so looking at these two, I have y equals 2 to the x graphed on the left, and I have y equals 5 to the x graphed on the right. Now, looking at these, you're probably looking at these and you're sitting there thinking like, how are both of these a parent function? But the reason why they're a parent function is, first off, their k is equal to 0 because they don't have plus anything right here. So this is going to be a plus 0. So that's the first reason why they're the parent. Second off is the way that they go. So they start down towards 0 and they both go to infinity as their range. Next thing, they both cross the point of 0, 1. So that's why right now, that's your parent function. That's how you can define it. Now continue to look at it. One thing that you will notice is that 5 to the x is a lot steeper than 2 to the x. So that's why each of them have their own parent. Now we're going to go through each of these and we're going to discuss the transformations. I'm going to write the transformation down below and I'm going to let you graph these on your own time. So starting right here, I have y equals 2 to the x plus 3. The plus 3, this is my k. So this means that I'm going to we're going to shift up 3. Because it's plus 3, it's on the outside, so exactly what we think. Next one is 2 to the x minus 3. This is still our k. So I'm going to go down 3. Okay, now we're going to look at y equals 5 to the x. So this is going to be this graph over here. Alright, so the first one, I have 5 to the x minus 4 plus 8, or plus 2. So x minus 4, this is our h value, and our 2 is our k. So h, it's on the inside. Imagine there's parentheses there. So it's going to be the opposite of what we think. So minus 4, you think it's going to go to the left, but it's really going to go to the right. So it's going to go right 4, which I'm going to write as R4. And it's plus 2, so it's going to go up 2. Alright, next one, 5 to the x minus 4. There's not an h, it's just 0. And we have minus 4 as our k, so it's going to go down 4. Alright, last one. 5 to the x minus 3. Minus 3 is up top, so that's our h. It's going to be the opposite of what we think, so it's going to go to the right 3. Okay, if you have any questions on these so far, feel free to pause the video and go back and re-listen to all of it. Oops, wrong way.
Alright, now we're going to look at y equals 2 to the x, and we're going to talk about how your calculator kind of lies to you. So, first off, if I were just to plug in y equals 2 to the x into my y1, so whenever I do that, I'm then going to hit second graph. So if I'm looking when my x equals 0, my y equals 1. And as we know, 2 to the x is a parent function because there's no h value and there's no k value, so it's a plus 0. So that means our asymptote is 0, which I'm going to call a equals y equals 0. Alright, so that means our range also is going to go from, oops, sorry, my pen kind of backed out. It's going to go from 0 to infinity. Okay, so at 0, 1, which we're kind of golden right now, so far it's just like our parent as it should be. Now when our x is 2, our y is 4. Then keep scrolling down. When x is 16, my y is 65,536. Okay, now I want to look at my graph going the other way. So when my x is negative 100, now I don't want to scroll until I hit negative 100 in my calculator. So I'm going to go back to my home screen. So I'm going to hit second mode. Then I'm going to type in 2, hit my caret, then negative 100, and then hit enter. Now for this, I get 7.8 times 10 to the negative 31. So what this is saying is that I'm going to take my decimal point and I'm going to move it to the left 31 times. So as we know, that's a really, really, really small number. And it's getting really close to 0. But it hasn't hit 0 yet. Now I'm going to plug in 2 to the negative 1,000. When I do this, I get 0. And as we know, we can't equal 0. We can't. So this is where your calculator shows an error. So what it's saying is that your calculator can't figure out this number because it's so small and it's so close to 0 to where it just can't figure it out. So you have to understand where your asymptote is and that your function can't ever equal that. Alright, next one. So what would the transformations be of these equations? So I have y equals negative 2 to the x plus 3. So since I have a negative out front, this is a reflection over the x. So that means, and it's plus 3, so it's also going to go up 3. So that means this function will look something like this. That's just a roundabout drawing of it. Alright, next one. Y equals 2 to the negative x plus 3. The negative is up top, right here. So it's going to reflect over y. Okay, and then it's going to go up 3. So that means it's going to look like this. That's, again, rough drawing. Okay, I got a minute 10. Alright, so this is the basic way to figure out the range. So say you have b to the x or b to the negative x, your range is going to go from k to infinity. Then, say you have negative b to the negative x or negative b to the x, your range is going to go from negative infinity to k. This is something that I would make sure you have written down, so if you need to pause the video, or if you need to take a picture of it, do that. But this is something that's going to help you tremendously in figuring out the range. Okay, we got 3 short little test problems, which I'm going to create in another video. So feel free to watch that video and hope this helped.